More than 250 experts in the traffic signals industry joined together in person to hear a range of papers here in Nottingham. These recordings are brought to you by AGD Systems, Colas, SRL Traffic Systems, Smart Video and Sensing, Vivacity and Unex Traffic.
Right then, good afternoon everybody, and welcome to Canford Bottom. So, to set the scene for you, the Canford Bottom roundabout is a Highways England, National Highways, whatever they're going to be, site, located in Area 3 towards the south coast, just outside Bournemouth. It's a 6-stream, 6-arm hamburger roundabout, where the A31 is the trunk road running from north to south and vice versa through the site. The other 4 arms are the local authority roads, and generally rather quieter compared to the trunk road going through it. And as to the presentation title then of Untangling Canford Bottom, just what are we trying to untangle and why are we doing that? So for Highways England and their maintainer Kia, the Canford Bottom roundabout is a source of various sort of concerns and complaints. It's known for its complex layout and complex operation and has a history of collisions and sort of reports of general driver confusion and mistrust of the layout and operation. And to further complicate things, as you can see on the image, it exit blocks quite badly in the peak hours, which is typically the evening peak, but also in holiday periods, as this site is on sort of prime holiday route towards the south coast and it can get really, really busy. Four-Way have been involved as part of a quick win re-optimisation project across a number of sites in Area 3, where we've been looking to identify problems at the site and implement measures that can improve the performance quickly and reasonably cost-effectively. And this presentation is just going to give a bit of insight to what we've found and undertaken at Canford Bottom and the effectiveness of those. Now, hopefully... if I do, how do I get that video to play? Click on it, there we go, playing video. So we first went to this site in late 2019 to get a good understanding of how it operated. And there we found 6 streams of link mover, all trying to work incredibly flexibly to adapt. But what we actually found was a great deal of inconsistency in the coordination of the signals. You couldn't get a consistent movement through either the cut-through on the hamburger or around the circulatory. Sometimes it would coordinate, sometimes it wouldn't. Drivers just had no consistency to what was going on, and that tended to lead to blocking of the short internal circulatory links, blocking of box junctions, and sort of just general driver frustrations with it. And on site, we tried to quickly make some sort of immediate improvements in the mover validation. And that's where we first came unstuck as part of a quick win, because there was nothing quick about understanding the operation of the site. Across 2 controllers, we had 31 pages of special conditioning and 129 conditioning timers. There was massive complexity in mover with none of it well documented. So trying to unpick what did what so that we could sort of work out what we needed to do to improve things proved impossible in the time we had on site. And yet, also, come the evening peak and we had exit blocking, the situation got worse as Move was just sort of overawed with that blocked exit and performance deteriorated. So much that normally in the evening peak UTC fixed time plan runs to give some consistency, but I never really thought it managed that congestion well. What we wanted to do was to improve this site, to give it greater resilience, greater coordination and reliability. But we knew we weren't going to be able to very quickly do that on site. So we had to sort of go away and come up with a bit of a plan. And what we wanted to do, rather than reverse engineer the site, because it was just so complicated, was to come up with a whole new plan for mover and a new style of mover. That was going to need new configurations and to switch the signal off and a whole load of TM to make those changes. So prior to doing that, as a kind of proof of concept, we went out to have a look at a CLF plan and running a week of CLF as a sort of that trial to prove that the way we were looking at trying to run some more fixed coordination to get that consistency was going to be appropriate. We were hoping to get this all ready for early 2020, but obviously the world events overtook us somewhat. So it took until late 2020 when, just before Christmas and out of lockdown, we were on site to do a CLF trial. Now, CLF, there's no rocket science in this at all. We just concentrated on getting the coordination through the A31 hamburger and getting that working really nicely. And just to give that brief explanation of what we did, as the A31 goes to green, it goes green on the approaches first, feeding into an empty reservoir which is held at red, and then shortly turns to green and allows all the A31 movements to flow green together. And we keep that at green under the CLF plans for sufficient time, different durations, different plans at different times of day. At the end of green, we close both A31 approaches together and run a fixed phase delay through the internal reservoirs and then bring them to red once they're cleared. Nothing revolutionary at all in that, but we found that performance worked really well on site. Even though it was a fixed time plan, we suddenly had drivers sort of behaving as if they understood what was going on. Trucks weren't coming to unexpected stops in the middle of the cut-through. So we knew we were onto something. We were also able to sort of hang the coordination of the circulatory off this as well. So the A31, we got that working and then brought the circulatory in, and again, that worked. With that, what we then wanted to do was take that sort of rigid coordination of CLF, but bring that back into Mover and that more flexibility in Mover, but retaining that tight control of the start and end of green. But to ease future understanding of this site, we wanted to make sure that we were going to simplify the operation. We didn't want it that was going to be pages upon pages on pages of special conditioning. So we had to look to how we could maintain this and simplify at the same time. And across a 6-stream hamburger, that was no small challenge. So to look at what we actually did, we looked first at the A31 for Mover. Just as we had done in CLF, how can we get that coordination and that tight start and end of green? Our biggest challenge is that our two ends of the A31 are on 2 different controllers in 2 different streams. Conventional Mover linking, I found, when you really want to get everything working in every direction, either starts to sort of lock it down as a fixed time plan almost, with a lot of conditioning to do that, or you have to allow compromises in the performance of one direction or allowing inconsistencies coming in. We wanted to avoid that. And my first reaction from my poor simple brain was saying, well, let's just bring everything all onto the same controller, the same single stream. We can keep all of our A31 movements in one stage and the circulatory in the next. It'd be easy. Unfortunately, it was beyond the scope of our scheme for the amount of recabling that we would have to have achieved and the amount of time with the signals off and the traffic management to do that. So we had to find a way to get this kind of single stream operation, but retaining this multiple streams across multiple controllers. And we kind of thought, well, hang on, we can do this in Scoot. And for those that are familiar with the concept of a Scoot multi-node, we can have one instance of Scoot controlling multiple nodes on multiple controllers as if they were one. Could we do the same in Mover? And we managed to establish a technique that did allow that to happen. So I've got the staging of the 2 controllers, so they're A31 streams on site, both very similar. Stage 1 was all A31 movements, stage 2, the circulatory. And we wanted to pair those together. So both stage 1s always started and ended together, and both stage 2s did exactly the same. And we've managed to achieve that with basically a simple link cable and some simple special conditioning. And all we do is from our northern controller, we pass vehicle detector information to the southern controller along the link cable, and we pass phase confirms from the north to the south. In the south controller, we pair the phase confirms from the north with those in the south to create a single stage confirm for each pair of stages. And we take all the detector information from both north and south and push them into Mover. We then configure Mover on the southern controller as just a single stream, as if it was one controller and one stream. Mover can then see and balance both the north and south of the controller. It sees it all in a single stream, combines that all together, makes just a completely conventional stage change decision, sends that back into the southern controller as either an F1 or an F2 force bit, which the southern controller reacts to, and it mimics it along the link cable to the north controller. And from that, we have a single instance of mover, a single stream of mover, which is then just controlling both of these two independent streams as if they were one. And from the moment we've turned that on, we had 100% reliable and completely consistent tight control at the start and end of green, with then mover able to vary the duration of green for both of the appropriate pair of stages. Yes, right, okay. However, what we are doing is adding inflexibility as a trade-off to get consistency. And to kind of make matters worse, where under CLF we ran a fixed phase delay to clear the internal reservoirs, we wanted a similar concept in mover, but that again adds long interstages and long amounts of lost time. And we wanted to see if we could buy back some flexibility, again with a fairly simple technique. Now, some of the latest controllers would have let us use a variable phase delay based on vehicle presence on detectors on the street, on the internal cut-through. But we didn't have that. We're on older 900 controllers. Not old, but they don't have that facility. And we wanted to see, could we create what we've called a sort of a variable phase delay alike, so that we could still use the existing vehicle detectors on the internal reservoirs to actually control a variable clearance period. And again, a fairly simple bit of controller operation has achieved this for us. We've put an intermediate pair of stages between our A31 and circulatories, which just purely runs the internal reservoirs at green. So the internal reservoirs continue green between stage 1, as I've called it here, 1A. At the end of stage 1, the controller alternate and prohibited moves always forces the controller via stage 1A, and we use the extend all red facility then to vary the all red on a dummy phase between stage 1 and 1A, which actually gives us a variable length of time that the internal reservoirs stay at green. So it's just the completely standard functionality in the controller of an alternate and prohibited moves and extend all red to give us this variable phase delay. And that's then on site, rather than having to run at a fixed 7-second phase delay, we've now been able to vary that between 3 and 7 seconds. So depending on just how quickly and how many vehicles are on that internal cut-through, we've been able to get back a little bit of flexibility and buy ourselves a bit of improvement on the lost time. And when we combine the elements of the variable phase delay and this sort of mover multi-node style operation together, we get to this. So the video at the top was the video you saw earlier, which was shot before we made any changes in late 2019. And the video at the bottom, looking in exactly the same direction through the cut-through, was shot this summer when we were out on site validating all these works in June. And the site was incredibly busy at that time. This was sort of peak holiday period. We've had exit blocking at this site from 7:30 in the morning. And I've just remembered something I forgot to say. From 7:30 in the morning, so sort of for 4 or 5 hours at a time, this site has been incredibly busy. But we have had 100% consistent and 100% reliable coordination through the cut-through that entire time. On the circulatory, we've had greatly improved and really, really reliable and consistent coordination around the circulatory. We're minimising the blocking of the internal box junctions and the conflict areas. We've even had this very rare thing of positive compliments on site, of pedestrians and drivers walking up to us or shouting from their vehicles when you're expecting abuse to actually say thank you. So I think from that we can probably take it that we've hopefully made some improvement at least to the performance. And we aim to simplify the control configurations. Well, I would never describe what we've done as being simple. It's a 6-stream hamburger site with mover on it. I'm not sure you would ever get that to a point of being simple. But I believe we've made it simpler. We've fully documented all the changes we've made and how the operation works, and that's stored both locally on site and with the client. But we've also managed to halve the number of pages of special conditioning in the controllers. So it's a big difference. On special conditioning timers, they're now running at 1/3 of what was there before. And in mover, we run at about 2/3 the total number of links. So whilst maybe not simple, I would say it's simpler. And if we combine that together with the increased performance, which hopefully should lead to reduced driver frustration, we think it's been a success. So thank you for listening. There you go, hopefully just before the red light.
Thank you, Tom. That was a very interesting review there of that system. I had a few questions here that I'd put down earlier on. It was very succinct and a good presentation. You obviously streamlined a lot of the phasing. There was a lot of traffic heads on that, what I could see there. How many were there? Upwards of 60, surely.
Yeah, across mover and across all the phases around the site and with priority links and everything else. I think I put some numbers in the paper that's in the book. But yeah, there's a lot of links, a lot of phases around that site.
A phenomenal amount of work in the background to get done. Obviously, we saw how the system was put together and how you've changed it and what have you. The obvious thing that everybody wants to know, you mentioned and you touched upon very quickly there about some of the positive comments you've had back. Any statistical analysis yet of reduction in traffic times or accident reductions?
I think the biggest problem causing congestion at this site is the exit blocking. Downstream of the site, it goes straight into a 2-to-1 merge and gets really sticky along the A31. That's the single biggest driver of congestion.
Right.
And this doesn't resolve that.
Okay.
It gives a mover system that's resilient to that and works well with it and can recover quickly from it. But it won't necessarily massively reduce congestion at its highest times.
Yeah.
When it's quieter and during those congestion, I would say it keeps things moving, reduces frustration, and hopefully makes the sort of signals rather more unobtrusive.
Sure.
They're not something to complain about. They're just something to pass through and go.
Yeah. Well, reducing frustration can increase safety because we know what humans are like when they get frustrated themselves.
Yeah.
Any just ideas on safety improvements in the area?
From what we saw out on site validating, we're seeing reduced amount of red light running.
Yeah.
The control is more appropriate to how people expect to use the site, and they're just not, without that frustration, they've not got the red light running. We've not done any analysis of accident history at the site. That wasn't part of our project, so I don't know the main cause of what have been the collisions there. It's only been in since June, so it's been a short while, but yeah, I've encouraged our clients, if they can, to go and a number of years' times to go and look at the accident stats and see if there has been a reduction.
Okay. Well, hopefully in 12 months' time you'll be able to come back and let us know.
Yeah, hopefully.
For now, ladies and gentlemen, Tom Sidall from 4-Way Consulting.